Good morning, students. Welcome to Mathematics 8, Quarter 4, Week 7. By the way, my name is Viola Roland Jr., your subject teacher in mathematics. So, our topic this morning is all about experimental probability. So, experimental probability is how many times an event occurs divided the total number of trials. So, just like here, for example, Maddie is eating a chocolate nip. She wondered how many nips of colors of each type are different in a pack. So, can she get a green color chocolate nip? She performed an experiment and recorded the data as follows. So, these are the data. So, number of each color: blue 8, yellow 5, orange 6, violet 4, red 7, and green 0. So, for our experimental probability, we have the formulas: number of times an event occurs divided by total number of trials. Example, the table above. What is the experimental probability of a chocolate colored nips? A. Experimental probability of orange nips. So we have 0.20. Experimental probability of blue nips, we have 0.20, 26.667. And experimental probability of green nips, we have 0. Example, Mrs. May Amor conducted a survey of her students whose birth months are January, May, June, September, November, and December. The table shows the result of her survey. So we have here, so A is find the number of students, B find the experimental probability distribution of each birth month, and C find the experimental probability of having a birth month on either March or November. So we have here the probabilities. So for January, we have 16.67%. For March, we have 11.11%. For May, we have 13.89%. For June, we have 8.33%. For September, we have 16.667%. And for November, we have 13.89%. And for December, we have 19.44%. Example number 3. A bag contains 3 red balls, 6 blue balls, and 4 yellow balls, 5 green balls, and 2 pink balls. Cheska picks up ball and writes down the result and puts the ball back. So the results are as follows. So these are the results. So number 1 question, what is the total number of trials? And number 2, what is the experimental probability of the red ball? And number 3, what colored ball is most likely to pick up? And number 4, what color ball is least likely to pick up? And number 5, what is the experimental probability that she will pick blue ball? So for the number 1, what is the number total of trials? So we have 20 total of trials. And for number 2, we have what is the experimental probability of the red ball? So we have 15%. And what color ball is most likely to pick up? So for number 3, we have blue ball. And what color ball is least likely to pick up? We have pink ball. And what is the experimental probability that she will pick blue ball? So we have 30% only. Probability of simple events. We learned that probability is how likely something to happen, or a measure of how likely an event to occur. You might also hear it called chance. So the more likely an event is to occur, the higher its probability. The less likely an event is to occur, the lower its probability. The probability can be expressed as fraction, decimal, or percentage. Simple event is an event which has a single outcome. So probability of a simple events. So the probability of an event is the number from 0 to 1 which tells how likely the event is to happen. Take a closer look at the probability line below. Rule number 1. So probability rules. So the probability of any event is a number, either a fraction, decimal, or percent from 0 to 1. Example, the female student population in a certain barangay is 52%, 54%. Number 2, if an event will never happen, then its probability is 0. Example, a set of months in a year that starts with a letter K. Since the sample space consists of January, so until December, it is impossible to get K as the starting letter of the month. Rule number 3. If an event is sure to happen, then the probability is 1. So when a single die is rolled, what is the probability of getting a number less than 7? Since all the outcomes are less than 7, then we have the probability of 1. Rule number 4. The sum of the number of probabilities the number of probabilities of all outcomes in the sample space is 1. Example, in a rolling pair die, each outcome in the sample space that has a probability of 1 over 6. Hence, the sum of probabilities of the outcomes is 1. The probability of an event is a ratio that compares the number of favorable outcomes to the number of outcomes. So P event is equal to number of favorable outcomes over number of all possible outcomes. Example, the spinner at the right spun once. Determine the probability of each event. So that's it. So for F, 0.1, for P vowel, for vowel 0.3, and for D or G 0.2. Complementary events are two events in which either one or the other must happen, but they cannot happen at the same time. The sum of the probability of an event and its complement is 1 or 100%. Miss Joy surveyed her class and discovered that 40% of her students had their assignment and identified the complement of this event. So, with assignment 40%, therefore without assignment is 60%, total of 100%. Sometimes getting an event affects the outcome of another event. Take a look at these examples. 2 green and 5 red marbles in the jar without replacement. So what is the probability that you will get a red marble? How did you get your answer? So what are your chances of getting a red one when you pick again? Do you have the same answer? Why? How many marbles are now in the jar? How many red marbles are there? So getting the next marble is affected by the result of the first attempt. Every time you get a piece of marble from a jar, the chance of getting a red ones will change. Rather, these are called dependent events. So number 2, tossing a coin. When you toss a coin, what is the probability of head landing up? If you toss it again, what is the probability of getting tails? The two events do not affect each other since the outcome of the first toss is head and tail is the same on the second toss. They are independent events. And and that's all our topic this morning. Thank you for listening and God bless. Bye bye.